Hello everyone, welcome to our YouTube channel. So this channel, I'm going to bring you educational videos from class 9 to 12. Okay, so we will be bringing you videos from science related subjects, science and mathematics. And in today's video, I'm going to discuss the chapter on motion from class 9. So today's video will be an introductory video. We won't be doing any numericals or problems, which I will do in a later video. I promise I will make you guys be confident in solving problems as well. But in today's video, I'm only going to discuss you the various topics that comes under this chapter. Okay, so the name of our chapter is motion. First of all, what do you mean by motion? Anything that changes its position with respect to time. You can say that it is moving or it is undergoing motion, isn't it? For example, right now I'm speaking, you can see me moving. So that's an example of motion. Our earth is rotating around the sun, which is another example of motion. The blood flowing through our veins and arteries, another example of motion. Motion can be in different ways. There are certain motions which we can feel by seeing, which we can understand by our vision. Many things we can see they are moving and we can say that, okay, this thing is moving. Then there are many other things which we actually don't see moving, but we know they are moving. For example, our air. When wind flows, we don't actually see air moving. Instead, we see dust particles moving or we see the rustling of branches, etc. From that, we get an idea that actually air is moving. So that's another way of motion. So in this way, there are several different kinds of motion. For example, even atoms, particles, they vibrate. So that's vibration is another kind of motion. Then at times, like I already said, the motion of Earth around the sun. So that's an example of circular motion where the object is following a particular path, which is a circle. So these are the different kinds of motion. Now, and also another important thing. Interesting fact about motion is that motion is a relative phenomena. This is not very important here, but let me give you an idea. For example, assume that you are in a bus, in a moving bus. Okay, a co-passenger, another passenger with you, even though the bus is moving, you might feel like the co-passenger is not moving, isn't it? But at the same time, when you look outside the bus, and you see a stationary man standing on the road, or you see a tree, but even though it's actually stationary, but if your bus is moving, you feel like the man or the tree is moving in the opposite direction at a very large speed, or that speed would be actually equal to the speed of your bus. So this is what meant by the concept of relative motion. Even though the man or the tree is stationary with respect to the ground, but for a person in the bus, in a moving bus, he seems like he is moving. Whereas for the person inside the bus, for another person inside the bus, you don't feel like the person is moving. Okay, so that's another point related to motion. Now let's discuss another another concept, like the origin. Like everything, like if you are describing the location or position of an object in space, we need an origin. That is, with respect to this position, you can say that the position of the another object is like this. For example, you are saying that your school is a 2 kilometer north from your home. See, here your reference point is your home. With respect to your home, if you move in a direction 2 kilometer north, you will reach your school. So that means what? That means the reference point, that is the home, is the origin. Okay. So that's about origin. Now, so you understood what's origin, what is location, how to describe the position or describe the motion. Now let's discuss about the most easiest form of motion, which is one-dimensional motion or motion in a straight line. So in this chapter, in the beginning part, we are going to assume that our particle or our object is moving in a straight line. Its direction is not going to change. At the end of the chapter, we will discuss motion along a circular path also. So for motion along a straight line, there are several physical quantities that needs to be studied. One such quantity is the distance. Okay, distance is nothing but, we know it, the name itself is obvious. From the name itself it is obvious. What is distance? If you move from one point to another point, the distance between those 2 points. That is the difference between the position of those 2 points will give you the value of the distance. Okay, now how is distance different from displacement? Displacement is actually the difference. It's actually it could be the magnitude of distance. It's like displacement is the distance between the initial and final position of motion. For example, you're moving from, say, Kerala to Delhi. Okay, and you're going back to, and the distance between Kerala and Delhi, let us say, is around 1000 kilometers. So assume that you are moving from Kerala to Delhi and you came back from Delhi to Kerala. So the total distance that you have traveled would be 2000 kilometers, isn't it? You're going there and you're coming back. But the displacement, which is the distance between the initial and final position, isn't it? It's the same. You are starting from Kerala and you are reaching Kerala. That means the total displacement is 0. So displacement can be 0. But for an object which has undergone motion, distance can never be 0. Okay, so displacement is, but if you are only considering the motion from Kerala to Delhi, then the distance and displacement are equal. Like it's the straight line distance between the initial and final position of an object is what displacement is. So displacement is distance with direction. Okay, so that's about distance. Now let us talk another concept called speed. So what is speed? The rate of change of distance gives you speed. That is the distance traveled per unit time. That is what speed is. So if you travel, let's say 50 kilometers in 2 hours, that means you have traveled 25. You have traveled at a speed of 25 kilometers per hour, isn't it? So that is the equation of speed. It's simply distance traveled by time taken. Okay. So often we introduce another concept called average speed. Average speed is nothing but the total distance traveled by the total time taken. Never forget this very important equation. Average speed is nothing but the total distance traveled by the total time taken. Okay. Now velocity is another concept which is parallel to this speed. In velocity, we also consider the direction. So these quantities like velocity and displacement were both direction and magnitude matters, whereas for points like speed as well as distance, only the numerical value matters. That is, only the magnitude matters. The direction is not relevant. So those physical quantities for which only the numerical value of the magnitude matters are called scalar quantities, and those quantities where both magnitude and direction are important are called as vector quantities. Okay, so these terminologies are not very important, but I'm just giving you the difference. So velocity is defined as the total displacement by total time. Okay, or it's the rate of change of displacement with respect to time. That is, displacement occurred per unit time. Okay, now there is another useful physical quantity which is average velocity. Average velocity can be calculated by two different ways. Either if the initial and the final velocities are given, average velocity is simply the arithmetic mean of the initial and final velocity. That is, if the initial velocity is u and the final velocity is v, the average velocity is u plus v by 2. Okay, whereas average speed was total distance by total time taken. Another way you can calculate average velocity is the total displacement divided by the total time taken. Okay, so that's about velocity and velocity, speed, distance and displacement. Now there is the concept of uniform motion and non-uniform motion. If an object is traveling equal distances in equal intervals of time, then we say that the object is under uniform motion. That is, if the speed of the object remains same, if it remains constant, we can say that the object is in uniform motion. Okay. For example, if the object moves like 2 kilometers in 1 minute, another 2 kilometers in the second minute, another 2 kilometers in the third minute, see, the distance traveled in equal intervals of time is the same. What is the interval of time here? 1 minute, isn't it? Whereas if the object travels 2 kilometers in the first minute, 3 kilometers in the second minute, 5 kilometers in the third minute, then that means the distance traveled per equal intervals of time are different. So that means the object is undergoing non-uniform motion. Okay. So that's about uniform motion, uniform speed. Okay. So we have discussed. Now we already know the formula for average velocity as well as average speed. Now next concept is acceleration. That is the rate of change of speed per unit time is what acceleration is. Okay, so if the speed of an object is increasing or decreasing in successive equal intervals of time, we say that object is undergoing accelerated motion. Okay, for example, the equation for acceleration is v minus u by t, where v is the final velocity, u is the initial velocity, and t is the time taken to reach the final position starting from the initial position. Okay, so that is change in velocity, change in the final and initial velocity divided by time. It gives us the total acceleration. So now what do you mean by uniform acceleration? Uniform acceleration occurs when the increase of speed in equal intervals of time is equal, or the decrease of speed or velocity for that matter in equal intervals of time is equal. That is, how do you say, if in the first 1 minute, if the speed of an object is 5 km per hour, in the next minute, if the speed of the object is 10 km per hour, in the third minute, if the speed of the object is 15 km per hour. So now the object speed is not constant. That means the object is not in uniform motion. It's in non-uniform motion. But the speed is increasing by the same amount, isn't it? It was 5, then it was 10. So that is, there is a change of 5. Then in the third minute, it was 15 km per hour. So there is a change of again 5 km per hour between successive equal intervals of time. So such a motion is called as accelerated motion, or a motion with uniform acceleration. That is, here the acceleration value is constant. But if the increase in speed is not equal, is not by equal amount, or the decrease in speed or velocity is not by equal amount. For example, in the first minute, if the object travels at 5 km per hour, in the second minute, if the object travels at 15 km per hour, in the third minute, if the object travels at 40 km per hour, see, the speed is increasing at a different way. It's not equal amount. The increase is not same. So that means this is a non-accelerated or motion. Okay, not non-accelerated. What do you say? Non-uniformly accelerated motion. Okay. So those are the different concepts. Now we can actually study these motions, these physical quantities with the help of graphs. You can plot distance, time, displacement, velocity, speed, acceleration, etc. with respect to time. Okay, so in a typical distance versus time graph, if you plot, if the motion is uniform, then the graph would be a straight line. Okay, and the slope of the graph, I will discuss these things later in detail in the next video. But the slope of the graph of distance time graph will give you the speed, and if it is a displacement time graph, the slope will give you the velocity. Okay, and then if you are plotting velocity versus time graph of uniform motion, then since we know in uniform motion speed remains constant, so the graph would be a straight line parallel to the time axis. And here, if you find the area under the velocity time graph, you can find the displacement. Okay, because displacement is what? Velocity is displacement by time. So displacement is velocity multiplied by time. So if you are finding the area under the graph of velocity and time, you can calculate the displacement. Okay. Similarly, for uniformly accelerated motion, in uniformly accelerated motion, if you plot velocity versus time, the slope of velocity versus time will give you the acceleration. Okay. Whereas the area under velocity time graph will give you again displacement. So a uniformly accelerated motion, the velocity time graph would be a straight line. Okay. Whereas for a non-uniformly accelerated motion, the graph won't be a straight line. So these are the things that is important regarding graphs. Now we have already discussed a few physical quantities, which was speed, velocity, acceleration, displacement and distance, and as well as time. So these physical quantities are interrelated. We have simple equations connecting them. Those equations are called as the equations of motions. I will discuss them also in detail in the next video. but I will just mention those equations. There are three equations of motion. The first one is v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. And the second equation is s is equal to ut plus half at square, where s is the total displacement of the object, u is the initial speed, and other remaining physical quantities as mentioned. And there is one more equation, which is v square minus u square is equal to 2as. Okay, the variables have the same meaning as mentioned. So with these equations we can calculate, if we have two of the physical quantities, we can calculate the third one. Okay, now in this chapter there is the final topic, which is circular motion, or more correctly uniform circular motion. So what do you think? An object is traveling along a circle, around a circle with a constant speed. Is it undergoing uniform motion? Actually, it is not undergoing uniform motion. Uniform motion, if you speak precisely, uniform motion is when object is traveling equal displacement in equal intervals of time. That means the velocity of the object needs to remain constant in uniform motion. Whereas when the object is moving in a circular path, even if its speed is constant, its direction is changing at each point, isn't it? So since its direction is changing, the velocity is actually changing. So the velocity is not constant. So we can say that the object is undergoing uniform circular motion. That is because the speed is same but velocity is not. So since velocity is changing, you can say that it is an accelerated motion. If velocity was also constant, it was a non-accelerated motion. So that's about circular motion. And in circular motion, when an object is moving in a circular motion, assume that you have tied a stone to a thread and you start to swirl it around. Okay, and you at a particular point you just dropped it. In what direction will the stone move? Stone will go in the direction tangential to the point from where it was dropped. Okay, so that means so because at each point that tangential direction was the direction of motion of that object, but at the very next point the direction changed. So in circular motion, as you can see, it's like the direction is changing at each point. At each point the direction is given as a tangent to the circle. Okay, so what I meant was that, so that is how we can calculate the direction of motion of a uniform circular motion, object undergoing uniform circular motion. And here the acceleration of the object will be towards the center. So these are the main concepts in this chapter. But this chapter is incomplete without solving the numericals. Once we solve the numericals and draw the graphs, you will get a better picture of the concept that is mentioned in this chapter. So the name of the chapter was motion, and I guess you have got an idea of what motion means. With this, I am concluding this video. Thank you.